Alright, this is a build of a benchtop power supply based on a PC power supply, which is a cheap high power supply. So what I did was I cut off all the extra leads that come with the power supply, and I put hot glue on the cut off ends just to make sure that they don't short out. I printed a circuit board which has this big connector, mating connector on it, and it has LEDs for each of the voltages and a power switch. And it also has a connector on the front which can mate to one of these standard PC cut type connectors. So I can use the cables that I cut off as power cables for other projects and plug them in here. And I have some terminals, binding posts, which will be mounted through this card, and they'll come out on the faceplate here. Okay, so one of the things I did was created some conical holes in the base of these, the chassis or the frame here, to accommodate these rubber feet. And there's actually holes in there which I could screw these things in, but because they're a conical hole, once I get them put in there, they're not going to come out. Of course, you need a pretty good squeeze to get them in there. So after I've put all the feet in, I'll continue this video. Okay, I've mounted the conical rubber feet into these conical holes in each of the chassis parts. Now I think we have to mount the binding posts. So they feed through from the front into, well, let's put the, yeah, they feed through from the front, and then we'll have to bolt them on from the back. So there's a little plate that goes on the back, in there. And we need a washer and a nut. It's pretty handy when you have a nut driver. This one needs a washer. Okay, so I'll put all of the binding posts on and then resume the video. Okay, the binding posts are on. Now here's the circuit board. The switch is soldered to the board, so it has a little flange on the switch, which is going to come through this hole. So I have a couple of little shells which take up the spacing between the edge of the hole or to cover off this flange. So they're going to go on here and make it look a little bit better. We'll have to feed that through from the back. One thing to note about this circuit board is that there are no vias No extra vias, it's just all routed with big traces on both sides, but no extra vias, so it's nicely routed. Well, there we go. Bit of a tight fit. Okay, now it's just a matter of screwing on all of these binding posts with more washers and nuts. Lots of nuts, lots of washers. They actually give you a lot more washers than you need, in case you're going to have a different arrangement of binding posts or a different arrangement of panels. And okay, tighten these up. Okay, that's in there nice and tight. We've got the connectors on the front, the binding posts, everything's good. I don't know if you can see this, but when I light it up, you'll be able to see that there's a little diffuser behind each of the voltage numbers down at the bottom here. Now let's put the let's put the power supply in the housing. This is a little tricky. Actually, before I put that in, the handle has to go in because it gets locked in by the power supply. There's a little hook at the back, but when the power supply is pushing on it, it can't come out. And it's going to be held in by the power supply, which is going to butt up against it. So, like that. So this handle can't come out at the back. And we have the power cables coming out the front. I guess we'll have to hook it up to this connector in here. Okay, there. So we've got the main power connector hooked up, and now all this wire has to fit somehow in there, and this goes on. This has never gone together before, so here we are. It's going to be like that. Now I have to put a couple of screws in there just to make sure it stays there. And one more on this side. Oh, that's not quite lined up. Here we go. You notice the bottom is open and there's some grating here to allow air to flow through that power supply. It has a fan at the back. Okay, so that's pretty solid there. One more screw. Hopefully this one lines up. Get this final screw in there. Here it goes. Great, so now we have a power supply. Let's plug it in and see if it actually works. There we go. So we can see, I don't know if you can see, let me turn off the lights. We can see that there's a minus 12, plus 3.3, plus 5, and plus 12. But there's no minus 5 on this power supply. It's on the connector, but it depends if the power supply actually puts it out into that standard connector. Very nice. And it's the first time I've tried it, so I'm not sure exactly what's going on with this power switch. It's not turning on the entire power. It's just activating the soft power connection for the power supply. So if the power supply ignores that thing, then this switch won't do anything. But bench supply, El Cheapo, coming from a normal PC. And putting back on the bright video lights. I kind of like that. And of course we can plug in a computer power connector there as well. So it seems pretty straightforward, pretty sturdy. The rubber feet work well. Lots of airflow happening in there. And that's what it looks like from the side. And let's see from the back. So the back, here's the fan. Yep. Lots of airflow can get in underneath here. And these are all standard spacing. So you can plug in banana jacks. So, nice little power supply, bench supply. I'll probably make good use of that. Okay, just to make sure that it's putting out the right voltages, here we're going to put in the ground wire, and we can read the DVM here. On here we got 11.9 volts. On this one we have 4.99. On here we have 3.35. And on the -5 we've got 0. On the -12 we have -11.429. So definitely working, and just about as good as you get from a PC-based power supply.